All right, let's look at the homework 5.6, problem number 8. All right, for this one, I'm going to completely use GeoGebra to answer all questions. All right, so here we have a definite integral from 0 to 9 of 1 over x squared with respect to x. All right, so we want to use trapezoidal rule with n equals 8. All right, so let's do that. So I'm going to open up GeoGebra. Alright, so first we need to put the function. So f of x is equal to, integrand was 1 over x squared. So I'm going to hit enter there. Alright, then first we're going to, let's see, define the lower limit. So I'm going to say a is equal to 1. Hit enter. Alright, upper limit's 9, so you have a b equals 9. Right, so we got that, and also number of rectangle n value is I think it was 8, so I type it in. Right, so we have that. All right, then what we're going to do is I'm going to define delta x. So here I'm going to say delta x. Right, delta x has a formula, right? So it's going to be b minus a over n. So we hit enter. Right? So we have a delta x value is given there. Right? So let's try to find the trapezoidal rule. Right? So I'm going to call this guy t. Right? It's equal to, and GeoGebra has actually a command for trapezoidal rule. So I'm going to type in so you can see that the trapezoidal sum. So I'm going to use that. Click on that. Right? Function is f, and start x value is a, and the end x value is b, and the number of trapezoid is n. And if you hit enter, it gives you the value. So you can see that we have a value here. Alright, so it looks like we want 3 decimal places. So I'm going to go back to GeoGebra and change the rounding to 3 decimal. It's actually already 3 decimal places. Alright, so we have that. Alright, so let's type in 1.034 in there. Alright, so we got 1.034. Alright, so the midpoint rule, we're going to have to do a little bit differently. Unfortunately, I could not find the midpoint rule from GeoGebra, so I have to tweak a little bit. All right, so midpoint rule can be created by doing this. They have a left sum, which is not quite the same thing as the midpoint rule. But what you can do is we can have the same effect by having a function here. And I'm going to shift the function to the left by half of delta x. So we're going to have delta x here and divide by 2, right? So it's shifted to the left by half of delta, right? Then we just have to do the same thing, start from a and that b, and then number of rectangle is going to be 8, right? So if you hit enter, we're going to have, actually, it's kind of hard to see here. I'm going to separate them, right? Then the midpoint rule, it came out to be 0.824, right? So let's type it in, right? 0.824, right? And then third one is we want to find the exact area. So I'm going to go back to GeoGebra. So if you want to find the exact area A, all you have to do is integrate, right? So we have integral. Let's see, I'm going to choose this one here, right? Integrating the function f from A, which is 1, to B, which is 9, right? If you hit enter, that's going to be the actual area value. You can see that it's going to be 0.889, right? So let's type it in. All right, so we have a 0.889. All right, so you can see that for some reason the midpoint rule is much closer to the actual value. So we can see here, let's see, midpoint rule is better approximation than a trapezoidal rule. Seems like this is the case, right? So let's check the answer. All right, I came back and looks like we got all of these guys correctly. All right, that's it. I hope that this was clear.